What is combustion equation? Write the combustion equation for different types of fuel. We know that when any fuel burns, it reacts with oxygen and produces combustion products and large amount of heat. The equation which represents the burning of fuel in the presence of pure oxygen is called the combustion equation. Thus, we can say that combustion equation is a balanced chemical equation which represents the burning of fuel in the presence of pure oxygen. It is different for different types of fuel. So let's write the combustion equation for different types of fuel. But for that, we first need to recall the atomic and molecular mass of some important constituents of fuel. First, let's write the combustion equation for a solid fuel. The main combustible constituents of solid fuel is carbon, hydrogen, and sulfur. Burning of carbon in the presence of sufficient amount of oxygen produces carbon dioxide and large amount of heat. Now, when we analyze this equation on the volume basis, we observe that 1 mole of carbon and 1 mole of oxygen produce 1 mole of carbon dioxide. And on the mass basis, we observe that 12 kilograms of carbon requires 32 kilograms of oxygen to produce 44 kilograms of carbon dioxide. Thus, we can say that 8 by 3 kilograms of oxygen is required for the complete combustion of 1 kilogram of carbon into 11 by 3 kilograms of carbon dioxide. Similarly, we can write the combustion equation for the other constituents as: the third column shows the corresponding oxygen requirement per kilogram of fuel constituents. Now let's write the combustion equation for the liquid and gaseous fuels. The main combustible constituents of both the liquid and gaseous fuels are methane, ethane, and hydrogen. Burning of methane in the presence of sufficient oxygen produces carbon dioxide and water and releases large amount of heat. Now, when we analyze this equation on the volume basis, we observe that 2 cubic meter of oxygen is required for the combustion of 1 cubic meter of methane. And on the mass basis, we observe that 4 kilograms of oxygen is required for the combustion of 1 kilogram of methane. Similarly, we can write the combustion equation for the other constituents as: the third column shows the corresponding mass and volume of oxygen requirement per unit of fuel constituents. Note that the liquid and gaseous fuels are measured in terms of volume, so the volume-based analysis is more important than the mass-based analysis.